Let's do a problem based on the last couple of lessons. An elevator has an initial upward velocity of 12 meters per second at level x, and it uniformly accelerates upwards at 2 meters per second squared. While it is at level x, a ball is fired upwards at 30 meters per second with respect to the floor of the elevator. So it would mean that the initial launch velocity of the ball would be 30 plus 12 or 42 meters per second from the ground frame of reference. Eventually, the red ball would land back on the floor of the elevator. We have to find the time of flight. And in order to do this, we will make use of the formulas that we had derived in the last couple of lessons. And in case you don't remember the formula, the concept that you have to remember is that the initial relative displacements and the final relative displacements would both be 0, and we have to substitute this into the second equation of motion. The formula for the time of flight is 2 times VA with respect to E over G plus A. We have been given that the initial velocity of the ball with respect to the floor of the elevator is 30 meters per second, and be careful that you substitute this value and not the speed from the ground frame of reference. The upward acceleration of the elevator is 2 meters per second squared. With that, we obtain the time of flight as 5 seconds. So it takes 5 seconds for the ball, which is fired upwards at level x, to land back on the floor of the elevator at level y. Let's find the maximum displacement of the red ball from the floor of the elevator, for which we had also derived an expression in the previous lesson. In case you don't remember this formula, in order to derive this, you have to understand that in the maximum displacement condition, the velocities of the red ball and the elevator are identical, so their relative velocity at that instant is 0, and we make this substitution into the third equation of motion. The formula for the maximum displacement is VA with respect to E squared over 2 times G plus A. VA with respect to E is the initial velocity of the ball, which is 30 meters per second with respect to the elevator and not from the ground frame of reference. The upward acceleration of the elevator is 2 meters per second squared, and we obtain the maximum displacement as 37.5 meters. And always remember that in this condition of maximum displacement from the elevator floor, it does not necessarily mean that the red ball is in its highest position from the ground frame of reference. The red ball could move higher than this, but the yellow ball starts traveling faster than the red ball beyond this point and reduces the distance between them. Finally, let's find out how much time is taken by the ball to reach this position of maximum displacement. To derive this formula, you again use the concept that for the maximum displacement condition, the velocities of the red ball and elevator are identical, so their relative velocity is 0, and we make this substitution into the first equation of motion. The formula is VA with respect to E over G plus A. So we get 2.5 seconds. And the surprising fact is that this occurs at exactly half the time of flight of the ball. The ball takes 5 seconds to land back on the floor of the elevator, and at 2.5 seconds, its displacement is the maximum from the floor of the elevator.